Now, I discuss here about some autosomal diseases. What is autosomes? Besides sex chromosomes, all of the chromosomes in our cells are called the autosomes. In human, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. 22 pairs of autosomes and one pairs is sex chromosome. Total equal to 46. One pairs, that is sex chromosomes, and all of besides sex chromosomes is autosomes. Some diseases which are responsible for the autosomes are known as the autosomal diseases, like thalassemia. 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 Thalassemia is the disease first coined this term from the Greek word that is thalassa, means the ocean. This type of diseases can found from the sea-oriented zone, that is Mediterranean sea-oriented zones. So it is called the thalassemia from the first finding zone of the diseases. What is thalassemia? Thalassemia is the disease which is responsible for the two separate autosomes. Then, according to their number of chromosomes, it can be defined as alpha thalassemia and beta thalassemia. What is alpha thalassemia and what is beta thalassemia? What is thalassemia? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That is 11. Sets of chromosomes. Number of chromosomes, sorry, sets does not means number of chromosomes, the diploid sets. 12, 13, 14, 15, 16. That is 16 homologous chromosomes. When this type of chromosomes cannot produce the certain polypeptide which is responsible for the making of hemoglobin, and the disease thalassemia is formed. The polypeptide which is found in 16 number of chromosomes is called alpha polypeptide, and this type of polypeptide which is found in the 11th number of chromosomes is called beta polypeptide. So the deficiency of this polypeptide, the 16th number of chromosome cannot produce the certain hemoglobin, and the disease is occurred is called alpha thalassemia. And when the 11 number of chromosomes cannot produce the certain hemoglobin which is made by the certain polypeptide, beta polypeptide, and this disease occurs and called the beta thalassemia. Now, I discuss here about the majority and minority. Major thalassemia, minor thalassemia, either that is alpha or beta. When if the hemoglobin of the alpha cells, if the dominant gene is alpha thal, and the recessive gene is alpha thal plus. That is the diploid set chromosome. That is 16 number chromosome and 16 number chromosomes. These chromosomes hold the alpha thal gene, that is the dominant genes, and these chromosomes hold the alpha thal plus genes, that is the recessive genes. Then alpha thal plus alpha thal equal to normal kind of human. This type of chromosomal set of 16 number chromosomes is found in any body. Those man shows their character as the normal type. But when any type of human can hold alpha thal plus, sorry, it is two mistake here. It is not normal. When the alpha thal plus and alpha thal plus, it is normal. I repeat, that is alpha thal plus, it is the recessive gene, and alpha thal plus is the another recessive genes found in the one set of 16 number of chromosomes, that is homologous chromosomes, represent the normal kind of human beings. But when it is here alpha thal, it is produce the heterozygous, that is the two separate genes found when it is the minor alpha thal minor, and that is heterozygous. Now we further know about this type of features. When the dominant gene of thalassemia, that is alpha thal, found in the one set of 16 number chromosomes, and another is the alpha thal plus is found, then these features can carry the alpha thal minor diseases in human beings. But when the two sets of 16 number chromosomes found the same categories, that is homozygous, type of chromosomes, where both two chromosomes can carry the alpha thal plus, then this type of chromosome sets holder shows their character as normal type of human beings. Now, when it is alpha thal and alpha thal, both two types are the holder of the dominant gene of alpha thal. What is this? Two type of dominant gene of thalassemia carried by the human shows their character as the major. This major that is homozygous recessive. Homozygous. three type of thalassemia we learn here, that is alpha thal normal disease that does not found, alpha thal minor and alpha thal major. Same type of thalassemia can be shows in the 11th number of chromosomes, that is beta thalassemia. When beta thal plus beta thal equal to beta thal minor, when beta thal it is major, and when beta thal plus beta thal plus it is normal. But beta polypeptide is a separate polypeptide, is different from the alpha polypeptide, which is three types of thalassemia shows in humans, that is beta plus, beta 0 and beta delta beta. Three types of beta plus, that is the enzymatic problem is so less, that is so lesser than the other type of beta thalassemia, and beta 0 is the so dangerous than the type of beta plus, and enzymatic problem is more than the beta plus. But delta beta, which is the less dangerous than the beta 0, so it is the most dangerous part of beta thalassemia, and it is called the coolest anemia. Now here I represent a small point square, that is minor thalassemia, that is P generation alpha thal plus alpha thal no, that is male into alpha thal plus alpha thal normal, that is female, and it is P generation, parental generation, cross each other and make the Punnett square for their that is alpha thal plus alpha thal plus alpha thal. This is alpha thal plus alpha thal plus alpha thal plus alpha thal, alpha thal plus alpha thal, alpha thal, alpha thal. That is the normal, that is minor, and it is the major alpha thalassemia type of first filial generations daughter. That is F1. Now we learn about the another autosomal diseases, that is the autosomal disease, that is Down syndrome. When we learn about the syndrome, then also learn the type of a mutation. What is mutation? Mutation is the drastic change of chromosomal and genetic functions and structures, and it is two types. One, gene mutation or point mutation, another is chromosomal mutation. What is gene mutation? When the change is found in gene, that certain genes and the point of the locus or point of the chromosomes, that is called the point mutation or gene mutations. But when the change is found in chromosomes, for the change of chromosomes, for the structure and functional change of chromosomes can causes of mutation is called the chromosomal mutations. Point mutations is two types. One, base substitution. Another is frame shift mutation. Base substitution and frame shift mutation. Base substitution is two types, that is transition and transversion. When a type of base, there are two types of base found in the DNA, that is the purine and pyrimidine. When purine is substituted by the another type of purine, is called the transition, that is adenine substituted by guanine or guanine substituted by adenine. But when the purine base is substituted by the pyrimidine, that is adenine substituted by the thymine or cytosine substituted by the guanine, it is called the transversion. So the difference is clear among between transition and transversion. So when the purine or the same base is substituted by the similar base is called the transitions, and the base is substituted by the dissimilar base is called the transversions. Frame shift mutations is the other type of mutations or point mutation or gene mutation. When the arrangement of genes where the polypeptide making sequence of amino acids can be changed, it is called the frame shift mutation. Now, chromosomal mutation. Chromosomal mutations is two types. One, the numerical and the structural. Numerical means the number of chromosomes, that is two types. One, euploidy, another is aneuploidy. What is euploidy? When the number of sets is the change, and it is called the euploidy. That is this two types. One is the haploidy and another is polyploidy. When the set is single, that is 23, the haploid set of human chromosomes, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 2 and 1, either X or Y. One set, that is 23, is the haploid set, that is haploid. When it is 2, that is polyploidy, that is diploidy, 2n. 3 set of chromosome, that is triploidy. 4 set of chromosome, that is tetraploidy. And 2 and greater than 2 sets of chromosomes found in the type of numerical changes or mutation, that is called polyploidy. It is 2 types: autopolyploidy another is allopolyploidy. When the same type of similar chromosomes is a multiplication, multiply each other and shows the polyploidy is autopolyploidy. But when the hybridization can take place and the dissimilar type of chromosomes is multiplied into the cells and shows the separate type, is called allopolyploidy, which is caused by the chemical, that is colchicine, the physical, that is physical matter, that is UV, ultraviolet rays, etc. All of the causes can create this type of polyploidies. Aneuploidy is when the set number is not changed, the chromosome number is changed. When that is 2n, the diploid set of chromosomes found in our bodies and cells, somatic cells. When 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 22, 23. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 21, 22, 23. When the one number of chromosome is, the single number of chromosome is disappear, it is called 2n minus 1, it is called monosomy. When the double number of chromosomes are disappear, that is 2n minus 2, 2n minus 1 minus 1, it is called double monosomy. When the sets of first chromosome is disappear, that is called 2n minus 2 equal to nullisomy. When the one number is exceeds the single numeral, that is called 2n minus 1, it is trisomy. I discuss about the trisomy. Trisomy is the syndrome. What is syndrome? Syndrome is the genetic appearance of the genetic disorder of the organisms. Many type of genetic disorders, when exposed as the features of their character, is called the syndrome. In 21 chromosomes here represent their 3 numerals, 3 sets. It is called 21 Down syndrome. 21 type of Down syndrome. Now, when this chromosome sets is autosome is 44 plus X chromosome, that is X chromosome plus X chromosomes, 1 is disappear, it is called Turner syndrome. When 21 autosome plus X and the Y chromosomes further is appear, it is called XXY, it is called Klinefelter syndrome. The features of Turner syndromes here is the physical features, it is the peculiar. The nipple is present, but the menstruation cycle is not found in this type of woman-like, but no complete woman. And the intelligence is so less. And Klinefelter syndromes is the another type of or genetic disorder, that is syndrome where the intelligence is so less and the peculiarity is found in their bodies. And the chromosomal structure is respectively Turner syndrome is here and the Klinefelter syndrome is here. Now, the structural it is two types. Structure is when the chromosome structure is various types, that is deletion, duplication, inversion, and translocation. What is deletion? When that is A, B, C, D, E, F, G, H. H is deleted. This deletion. It is called the normal deletion, terminal deletion. But when C is abolished here, it is called intercalary deletion. That is terminal deletion and intercalary deletion. Duplication, various types, that is A, B, C, D, E, F, G, H. It is normal duplications. When A, B, C, D, E, F, G, F, G, it is the tandem duplication. That is direct tandem duplications. When that is, repeat here, ABCD is same, but E, F, G, F, G, G, it is the opposite tandem duplications present here. And displaced when A, B, D, C, G, F, E, G, E, this displaced tandem duplication type of structural mutations found in chromosomes. Inversion, when the chromosomes arm is deleted and repeat make the chromosomes moving at 180 degree turn. It is called inversions. And translocations, when the one set of chromosomes can delete it and make the another tail of chromosomes is called translocations. So all the chromosomals and new genetic mutations I tell you.